Hello everybody, welcome to the ETABS and SAVE course. Now in this lecture we will begin to define our section of the project. We will define this section with the dimension mentioned in the presentation, and then when we run the software we will check them if we want to increase or decrease the dimension of each element. So we go to the dimension. We show that on the slide 5 we show that all columns on this project are with dimension equal to 600 by 250. So we return to the ETABS. We go to define section properties. ETABS define the columns and beams as frame section. So to define columns and beam, we go to frame section. These are a standard material that are an ETABS. So we can delete them. When we press on delete multiple properties, delete frame section, we select all the section. One section must be and this windows. So we began to define our material. So we go to add a new property. We want to define a concrete concrete columns, rectangular concrete columns. So we go to concrete rectangular section. We name the column as his section. We named the column as its section 600 by 250. We name it as centimeter. The material of the column equal to 30. As the we know FRMC equals 30 megapascal for vertical element, columns, wall, and foundation. So we name the column, we put its material. Now the depth of the column equal 600 and the width equal to 250. Okay, so we define the section, material, and the name, and we go to reinforcement and modify show reinforcement. We check, we select here to tell ETABS that is a column, and we go to the bar. We use T420, and for ties bars stirrups we use H240. So if we press OK. So we define the column. Now we can delete this section. Okay, we continue and the frame properties to define the beams mentioned and the presentation for our project. We have and the story one. Here we have one kind of beams, one type of beams, hidden beam, B 100 by 38. So we go to add a new property. We use rectangular concrete beams. The material of the beams, we name first of all we name the beam by, and the material equal FRMC equal 25, because here we told that FRMC equal 25 megapascal for horizontal elements, slabs, and beams. We return to the ETABS. The depth of beam equal 380 and the width equal to 1000 millimeter. Okay, we go to reinforcement. We select that we tell the ETABS that it is a beam, and the longitudinal bars material equal to 420, and the stirrups ties steel rebar equal to 240. We press OK. We continue with defining the beams. We have and the story 2 we have the same beams plus a drop beam with section equal to 25 by 75. So we return and add copy of material B 25 by 75, and here we put 750 and here 250 drop beams. Okay, and here because we select add copy of material, the rebar material and design tab are same. We continue for defining the beams, and the story 3 we have the same beam, we defined it. For story 4 flat slab we have a drop beams with section equal to 25 by 60. Add copy B 25 by 60, we put here 600, then okay. Finally, and the story 5 we have a beam with section 25 by 50. Add copy, here we have 500 B 25 by 50. Okay, so we terminate from defining the beams and columns. Here we press OK. Now we want to define the shear wall thickness, and the next session we will talk why we use shear wall, why system, and why R equal 5.5, and we define the other systems. Now we will just define the thickness of shear wall. Shear wall are a wall to resist against the earthquake load. We will define the section of this wall. We go to ETABS, define, section defines, to wall sections, wall section. We modify these sections. We name it shear wall. F'(C) of shear wall equal 30. Okay, and the thickness equal to 400 millimeter. We check it after, and we press OK. And the wall properties, we will the retaining wall of this project equal the thickness of the retaining wall and this project equal to 30 centimeter equal to 300, and F'(C) equal 30. Retaining wall, we name it retaining wall. Okay, we terminate from defining the wall. This is the retaining wall, and this is the shear wall with section equal 400 millimeter, F'(C) equal 30, shear wall name, and this is the retaining wall and the story 1. Okay. Okay. Now we go through this to define the slab section. We return to the presentation and story 1. And story 1 we have a waffle slab type 1 with thickness equal to 38 centimeter. We go to the ETABS, return to the ETABS, and go to section properties. The ETABS section properties, slab section. We delete the first section and we modify slab 1. We name it waffle slab type 1 with F'(C) equal to 25. The type of the slab is waffle, so the overall depth of this slab, we choose the overall depth of this slab equals 38 centimeter. We return to the tabs, we put here 380. The slab thickness is the topping of the slab. We go to topping of the slab, we have that equal to 8 centimeter, so equal to 80 millimeter. The step width at top and the step width at top is the width of the ribs of the waffle slab. And waffle slab, we put always the step width at top equal to 200 millimeter and the bottom equal to 200 millimeter. The same width for top and bottom for the ribs. Now the spacing along direction 1, we must know that ETABS call direction for direction X, call it 1 axis direction. For direction 1, ETABS call it 2 axes. So direction 1 is X direction and direction 2 is Y direction. Spacing of ribs and the 2 direction for waffle slab type 1 equal to, we show here because it is type 1, 160 centimeter equal to 1600 millimeter. we press OK. Now we want to define the waffle slab type 2. We press add copy of material. Waffle slab type 2 is the same section of waffle slab type 1, but the spacing between ribs change. So the same definition, but we change here, we put it 800 millimeter. Waffle slab type 2, S equal 80 centimeter, and the presentation we show it here. S1 equal S2 0.1 meter. For waffle slab type 1, S1 equal S2 equal 1.6 meter. So we return to the ETABS. We press OK. Now for solid slab, for ribbed slab, we name it ribbed slab. F'(c) equal 25. The type of slab equal is ribbed slab. The overall depth of ribbed slab from the presentation equal 38 centimeters. So we put here 380 millimeter. The slab thickness equal to 80 millimeter. For ribbed slab, always the step width at top equal to, we show here this section. This is the step at top here, the spacing of the step at top, and this is the step spacing the step of bottom. Always for ribbed slab, the step width at top equal to 125, and here the step width at bottom equal to 150. This ribbed and always for ribbed slab, the spacing between the ribs equal to 55 centimeter, equal to 500. These are a standard section for ETABS for ribbed slab. So this ribbed spacing step and step at bottom and at top and bottom, and the slab thickness. This number are always in ribbed slab. Now we want to put the direction of the ribs. Here in our project, the ribs are in the Y direction. So we return to the ETABS. We put the rib direction parallel to local 2 axis, because 2 is the Y axis. We press OK. Now we want to define the flat slab. We name it flat slab, and we go the type of the flat slab and solid slab is here, and ETABS is a slab. The thickness of the slab of flat slab here on our project equal to 20 centimeters. So we put 200 millimeter. So we define the flat slab. The same for solid slab. The thickness of solid slab equals 16 centimeter in our project. We press add copy of property. We put it 160 millimeter, and we name it solid slab. Okay. Now we determine we want to define the stair. We tell before that we can define the stair as solid slab with thickness equal to 18 centimeters. So we return to the ETABS. We go to define section properties slab. Add the new properties. We name it stair with material equal F'(c) equal to 25. The type is slab and thickness 180. So now we terminate from defining all the section and this project: slab, beams, columns, shear wall, and retaining wall, and the stair. And the next session we will begin to modeling and drawing the model. Thank you for listening. We'll continue in the next session.